I'm Dishan Otieno. I have a machine learning project whereby I'm predicting the electrical power output from a combined cycle power plant. So from the description, we have been given temperature, ambient pressure, relative humidity, and exhaust vacuum as our input features, and we have been given electrical output PE, which is our target variable that we are trying to predict. So we will start. Sorry, sorry for that. Sorry for that. So we will start by importing our pandas and numpy libraries, which they help us to read the nine-dimensional arrays. Then we upload our dataset into the Jupyter notebook by using pd.read_csv. Then this is the name of our data. So this is the dataset that we shall be using. Yeah, this data I obtained from Coursera from a machine learning project. So we assign x and y values. So I took 80. 80 is temperature, which I'll be using as my input, and my output is the electrical power output, which is PE on the y-axis. So first of all, it's good in any machine learning project to explore your data, to know the information that the data has, to check the data types, the counts, null values, and columns. Then go ahead and know the description that your data has, the count, mean, standard deviation. This is good because it helps you to know how you will train your model. Yeah, so let's start our training. So here we are visualizing our data set to know how our input features they are related to the electrical power output and also other observations. Yeah, so this is a pair plot. PE is our output feature, then kind is the scatter that we are trying to draw. So this is from Seaborn library. Then we start with a linear regression model. Linear regression is one of the simplest models that someone can start with to train his data. So from sklearn, you import the train test split. It is good to split your data to separate from the training data and the test data so that you can obtain the best results. So you split your data. After splitting your data, we import the linear regression model from sklearn. After importing the linear regression, it's good that you fit your data using the regressor.fit. Then you obtain the intercepts, the regressor intercept, and the coefficient. So the intercepts, as you know, they are obtained from the equation of a straight line, whereby y is equals to mx plus c. C is the intercept, and x is our coefficient. So I used b0 and b1. b0 is my intercept, and b1 is my coefficient. Then I obtained the correlation. I drew the correlation matrix to know how my input features they are related to the output feature, and to know how all the inputs that have been given they are related to each other. So you can do that using a correlation matrix. You want to know what kind of value, what specific value is your input feature related to your output feature. Then it's good to use a correlation matrix. Okay. So after drawing the correlation matrix, now I obtain my y prediction. So my y prediction It's the electrical power output which I'm trying to predict from the combined cycle power plant. So these are my predicted values that my model has predicted. So y prediction is equals to regressor dot predict x test. X test is the data that you splitted at the top. So these are the values that my model has predicted. So here I'm trying to comparing the test set of PE and the predicted values of PE. So this is the test data, this is the predicted data. So as you can see, my test data is related. It has a close relation to the predicted values of power output. We have 431.23, we have 434.97, we have 460.01, 459.03, 461.14, 464.67. So what does it show? It shows that we have a kind of close relationship between the testing data and the predicted output values. So this shows how good our model has done its work in terms of giving us the predictions. Let's go ahead. Then one of the very important things is to know the metrics of your data. How good your data is, how good your model is, how good your model is. How has it reduced or how has it minimized the error? We use the mean squared function from the sklearn matrix. So as you can see, you have got a mean squared error and the root mean squared error. So it's too low. The mean squared error is too low. So the least the mean squared error, the good your model is. Yeah. So here it's also good to go ahead and visualize your training data set. Compare it to your predicted values. So you draw the scatter plot of the training data set and you draw a line of best fit from the linear regression model. So a line of best fit that shows how good your predicted values are. So plt.plot xtrain.regressor